Hey everyone, and welcome to The Explainer. I am so thrilled you're here today because we are tackling a massive, complex, and honestly, sometimes intimidating topic. We're going to break it completely down. Today, we're unboxing artificial intelligence. Now, for just a minute, I want you to completely forget the media hype, the corporate buzzwords, and all those sci-fi movie tropes. In this explainer, we're going to look at the concrete reality of what AI actually is, how it functions on a mathematical level, and where this monumental technology is ultimately headed.
Listen to this for a second. Artificial intelligence holds many promises for humanity, but it could also pose a more dangerous threat than the nuclear bomb. Now, that is not just hyperbole. We're talking about a technology that has the potential to completely redefine human existence. And because the stakes are literally that high, it is absolutely crucial that we look past the surface and truly understand the mechanics of what it is we're actually building.
So here is our roadmap for today. 1. The evolution of AI. 2. How neural networks work. 3. The quest for AGI. And 4. Ethical risks and dilemmas.
All right, jumping right into Section 1, the evolution of AI from Turing to today.
You know, to understand where we're going, we really have to look at how we got here. The history of AI isn't this straight, predictable line of constant progress. It's actually a fascinating roller coaster of extreme highs and crushing lows. In fact, researchers often describe the history of this field in terms of seasons. An AI spring or summer happens when a new breakthrough leads to explosive optimism, wild promises, and just massive waves of funding. But historically, when the technology inevitably fails to meet those sky-high sci-fi expectations, well, society falls right into an AI winter. That's a period of deep skepticism where funding totally collapses and the field just stagnates.
Let's look at a quick timeline to anchor this. Back in 1950, Alan Turing proposes his famous test for machine intelligence. By 1956, the actual term artificial intelligence is officially coined at a Dartmouth workshop. And fun fact about that workshop, it was basically just a tiny handful of optimistic mathematicians who genuinely thought they could solve human intelligence in a single summer. I mean, they obviously couldn't, but they kicked off a massively optimistic AI summer. Fast forward to the 1970s, reality set in. The early symbolic, rule-based logic just couldn't handle the messy complexity of the real world, and that triggered the first AI winter. It wasn't actually until the 2010s, specifically a massive deep learning breakthrough in 2012, followed by the transformer architecture in 2017, that our current explosive AI summer really began, driven by massive amounts of data and computing power.
Before we leave the history behind, I have to point out this absolutely brilliant paradox coined by John McCarthy, one of the original founders of the field. It's called the AI effect. Basically, it's this bizarre human tendency to just stop calling a technology AI the moment it becomes a reliable, everyday tool. Think about it. When an AI beats a chess grandmaster, or flawlessly translates languages, or predicts the next text on your phone, we casually just call it software, or a neat feature. AI always feels like this magical moving target situated somewhere out in the future, rather than the reality we are already living with every single day.
Moving on to Section 2. How neural networks work. The math behind the magic.
So, we're shifting from history to mechanics now, and I'm going to warn you with a smile. We are diving into the math, but I promise we'll keep it totally accessible. It is time to understand the actual engine driving this current AI summer. The single most important concept you need to grasp is this. Training does not mean the model memorizes answers. It learns statistical shortcuts across thousands of patterns. An AI does not think about a problem, and it certainly doesn't read a sentence the way you and I do. Modern AI is, at its core, highly advanced, nonlinear statistical pattern matching. It works so well simply because the world, our language, our images, our behaviors, repeats itself.
So how exactly do we teach a machine these patterns? Well, there are three core paradigms of machine learning. First up is supervised learning. This is where you feed the computer labeled data, like millions of pictures clearly tagged cat or dog, and it learns to map the input to the known correct answer. Second is unsupervised learning. Here, you hand the AI a massive pile of completely unlabeled data, and it just discovers hidden structures and groupings completely on its own, which is super useful for things like e-commerce recommendations. And finally, reinforcement learning. This is pure trial and error. The AI explores an environment, gets a mathematical reward for doing something right, and slowly learns highly complex strategies. This is exactly how an AI learns to beat human champions at the board game Go, or how it learns to navigate a physical robot.
To actually execute these learning paradigms, we use artificial neural networks, which are roughly inspired by the human brain. You can kind of think of it like a three-part assembly line. You start with the input layer, which takes in the raw data, let's say the pixels of an image. Then you have the hidden layers. Now this is where the real magic happens. Deep learning models can have dozens or even hundreds of these hidden layers, passing the data through millions of artificial nodes. Every single connection has a weight and a bias, which you can basically think of as millions of tiny volume dials. Finally, the data reaches the output layer, which gives us our final prediction.
And this three-step breakdown beautifully illustrates the learning process itself, which is known in the field as the backpropagation algorithm. Step 1, the network takes a guess. Step 2, it checks how wrong its guess was compared to the correct answer, and then it reaches back through the network to slightly adjust all those millions of volume dials, the weights. Step 3, it repeats this process millions of times. Believe it or not, this simple, repetitive trial-and-error math is the true, somewhat unglamorous engine behind the entire modern deep learning revolution.
All right, Section 3, the quest for AGI, the holy grail of AI.
Now that we know how the engine works, let's look at where we're actually driving. Everything we've discussed so far, that is just preparation for the next monumental leap. The crucial point here is understanding the difference between what we currently have and what we want. Today, we have artificial narrow intelligence, or ANI. Narrow AI is incredible, no doubt, but it is highly restricted. A chest AI cannot suddenly generate a poem. A medical imaging AI cannot hop in and drive your car. They just cannot generalize. But the holy grail for companies like OpenAI and Google is artificial general intelligence, or AGI. AGI would be a system that can transfer skills across completely different domains, possess actual common sense reasoning, and solve completely novel problems without needing to be manually reprogrammed. It would essentially mimic the flexibility of the human mind.
So, why does this relentless pursuit of AGI matter to you and me? Take a look at this number, 80%. That is the percentage of workers who could see their jobs impacted by advancing AI, according to an estimate from researchers over at OpenAI. We aren't just talking about abstract computer science experiments anymore, folks. We're talking about an impending, massive shift in global economics, labor, and human purpose. The closer we get to AGI, the exponentially higher the stakes become.
Which brings us to our final section, Section 4, Ethical Risks and Dilemmas, the Dark Side of the Code.
The exact same mathematical architecture that makes these neural networks so incredibly powerful is exactly what creates massive, unprecedented vulnerabilities for us. To understand the risk, we have to understand the black box phenomenon. Remember those millions or billions of tiny adjusted weights we talked about? Because there are so many of them, the internal logic of the network is fundamentally unreadable to human beings. The input goes in, the output comes out, but the space in between, it's a complete black box. Now, if an AI is just playing a video game, a black box is totally fine. But when a black box AI is deciding who gets a mortgage, making a criminal sentencing recommendation, or generating a life or death medical diagnosis, and literally no human on Earth can explain exactly how it arrived at that decision, that lack of transparency becomes genuinely terrifying.
And the crazy part is, the black box is really just one piece of a much larger ethical landscape. We are dealing with inherited data bias. Because AI trains on human data, it inherently replicates and actually amplifies historical human discrimination. Then we have the looming threat of job displacement and economic inequality. We also really have to consider the massive environmental footprint. Training these models requires unbelievable amounts of electricity and water. Furthermore, there are severe security risks, like AI-powered biological design potentially being misused to create dangerous pathogens. And overarching all of this whole shebang is a severe lack of legal accountability. Our laws simply have not caught up to the code. All of those current, present-day risks lead us to the ultimate existential hurdle facing researchers today. It's known as the alignment problem. Think about it. If we actually succeed in building an artificial general intelligence, a system that could potentially learn and act way faster than human comprehension, how do we ensure that its goals are actually aligned with human values? It's a classic genie-in-a-bottle scenario. An AI instructed simply to solve climate change might logically deduce that eliminating humans is the most efficient solution, unless rigorous safety constraints are flawlessly encoded right into its core. And that brings us to the final, provocative question I want to leave you pondering today. If we eventually build artificial general intelligence, how do we ensure its goals align with human survival? We are building systems that learn through cold, hard statistics, not through empathy and not through morality. The technology is advancing rapidly, shifting from simple mathematical algorithms to powerful entities that will undoubtedly shape our future. Thank you so much for joining me on this explainer. Keep learning,
keep questioning, and I will see you next time.